All right, so read this on your own. Try to draw a picture. Okay, so I didn't really do too much. It should look somewhat identical to the ladder problem, right? But we have our plank, and I have P equals. Do we know what P equals? Yes? 5. Do we know what dP dt equals? 0. Good. The length of the plank is not changing at all. Okay? I also put some arrows on my height and my base. I said H equals and B equals. And I put some arrows to kind of help me visualize what's happening here. This plank is being dragged up the wall by a construction worker that's like standing at the top of a building. Okay? So that length is increasing. So dH dt should be a positive or a negative?
Positive.
Should be a positive, and I'm not going to get into the number yet. And as that's getting pulled up, the bottom is dragging along the ground. Agreed? And so dB dt should be what kind of number? Okay, so at least have your kind of finger on the pulse there that this should be positive and this should be negative is a good thing. When they tell us that the worker is pulling up on the rope at a rate of 0.15 meters per second, what is that? The dB dt. I don't think so. Bryce is shaking his head no. I think it's the dH dt. He's pulling up on the rope at that rate. So the rope is attached to the end of the plank, I would assume, since he's standing on a roof pulling this thing up. So this is 0.15. And then looking now at their question, you can be more confident of that. How fast is the end of the plank sliding along the ground? So this is what they're looking for, dB dt. Specifically when it is 2.5 meters from the wall. So what's 2.5? B. Now again, that's not a constant, right? It's right here, let's say it's further than 2.5 feet away, but it's dragging more and more closely, and eventually it'll be 2.5 meters away, but then it will very soon after be even closer as it continues to be dragged. So right at that instantaneous moment in time when it's 2.5 meters from the base, they want to know the speed at which it's moving. Okay? So what equation should we start with here, Bryce L?
P squared plus B squared equals H squared.
Say that one more time.
P squared plus B squared equals H squared.
Make sure you have your Pythagorean theorem done right. What's the hypotenuse?
Is 5.
Right.
That's
Right. But
H squared plus B squared equals P squared.
yes, H squared plus B squared equals P squared. Now, again, because the plank is always 5 and is never changing, we can use a P of 5 before we differentiate. So 5 squared is 25. We cannot do that for H and B. So now we differentiate. What's the derivative, Elise?
2H times DHDT plus 2DDDT equals 0.
Perfect. And then we're just going to slowly plug in what we know. What do we know, Morgan? Okay, what's H? Say it again? That's our B. That's B. But we can put that in. 2 times 2.5. Okay. What else do we know? P? We already used that, though. Because that was a constant, we got that right out of the way. DH dt is 0.15. Can't we find the H by doing the Pythagorean theorem? What do you guys think about that? Yeah. At the moment when B is 2.5, the Planck is always 5. So, yes, you can find the H. It's always going to be making a right triangle. So, H squared plus 2.5 squared equals 5 squared is going to find H at this exact moment also. So, 2.5 squared. Oh, I hate not having a calculator. I know. I tried. I said to Mrs. Hill, don't they get a calculator for this? She goes, no. I said, oh, okay. Shoot. I'm trying to sneak one in there. So it's going to be 6.25. 25 squared, actually, we should know is 625. That was silly. So 6.25. So I'm going to subtract 6.25 from both sides. H squared equals 25 minus 6.25. 18.75. I wonder if this would have been easier with fractions. Like, had I done 5 halves? Huh?
You said too late now.
I almost feel like it would have been. Wait, if I had done H squared plus 5 halves squared equals 25, then I would have been subtracting 25 fourths from technically 100 fourths. So H squared would have been 75 fourths, and then when I took the square root of both sides, H would have been, H has to be a positive number, right? So we don't need the plus or minus. Would have been root 75 over 2, which would have been 5 root 3 over 2. I actually do think I like that better. And I think that you will too, because more things will cancel. So H is 5 root 3 over 2. 0.15 is the same as 15/100ths, which is 3/20. Agreed? Plus 2 times 5 halves. dB dt is what we're looking for. That was a good decision. I like that. Fractions actually is easier here. So your 2 will cancel there. Your 2's will cancel there. Your 5 and your 20 are going to become 1 and 4. So I have 3 root 3 over 4 plus 5 dB dt equals 0. And then we'll get dB dt all by itself. 3 root 3 over 4. I think because the problem is given to you in terms of decimals, it was definitely easier at first to just look past that and just use the decimal numbers that they gave you, but once we started getting over here, I was not a fan. So now subtract the 3 root 3 over 4 from both sides, so 5 dB dt equals negative 3 root 3 over 4. And then I divide both sides by 5, aka multiply both sides by 1/5. And dB dt equals negative 3 root 3 over 20. Not great, but it is negative, which we anticipated that it should be, correct? So that makes me feel good. And another question that is not on your paper, but I want you to write down. How fast is the angle between the plank and the wall changing? Assuming at the same point in time that we've been working with for part A. Whose jersey is that, Dan?
Jared Rose.
Mm-hmm. Guess whose name's on the back of mine?
Paul Pierce.
I hate Paul Pierce. I don't hate him.
Larry Allen.
I liked Ray Allen a lot. I loved Kevin Garnett.
Is it a current person?
No.
I said Larry Bird.
Also, you see my number?
No.
My new age. My new age.
7:30.
Mm-hmm.
I didn't even see the number, I knew that in my head.
You knew that Larry Bird was 33?
No, I knew your name.
Oh.
I knew Larry Bird.
I was gonna say. Alright, we have that written down?
Other classes.
Is that me?
Getting nickel and dimes here, is it?
Oh my gosh, I was way more ahead than I thought I was. Thank you. I got all these copies I didn't know I made. Alright. So, where is this angle?
Top left.
Between the plank and the wall, Dan says top left. Does anybody disagree? Raise your hand if you agree. Good. Just making sure you weren't playing silent on me. That's the plank, that's the wall, so there's our angle. How fast is that changing? Now, visualize, just to get a feel for if we expect positive, negative. If the plank is moving up the wall and the plank is eventually like this, what do you think happened to that angle? Did it grow or did it shrink? Shrink. So we should expect d theta dt to be negative. Okay, so just to kind of get a feel for what our expectations are. What trig function do we want to use? Sine or cosine? Raise your hand if you think sine. Raise your hand if you think cosine. Sine wins. So we're going to do, I honestly, they're both going to present their challenges, but all of you wanted to involve the plank, which is the best choice. So, sine 1, I said. So we're going to do sine theta equals opposite. What am I going to use for the opposite? B. Over hypotenuse, what am I going to use for hypotenuse? 5. Good. So you guys know you're using the B for the opposite because that's not a constant number. At the moment, yes, it's 2.5, but it's not a constant number, whereas we can use 5. So that's the same as 1/5 B, by the way. So when we take the derivative, whose voice haven't I heard yet today? Emily, what's the derivative of this?
Cosine of theta d theta dt equals 1/5 b or dd dt.
Good. Perfect. So what can we plug in? Okay, dB dt is not pretty. Let's go left to right. Gina, what can we plug in for cosine theta? .15 what? that's a good point, I'm glad that you asked that. You always, when you're just finding the cosine of the angle, you're talking about the actual length of your triangle side, so you are not using the rate. No, -3 radical 3 over 20 was the rate. So the adjacent side to theta is h, and our h, yes. You had started to say that, then you went away from it. So that's our adjacent, 5 root 3 over 2, over our hypotenuse of 5. Well, that's nice because your 5s are going to cancel. Yes? Do that right away. Times d theta dt is what we're looking for, equals 1/5, and dB dt, we're using our -3 root 3 over 20. And so we just really need to get rid of the root 3 over 2 by dividing it away, aka multiplying by the reciprocal, which is 2 over root 3, and that'll lose that for us. So d theta dt is, what can we chop off here? Two and 20 reduces to 1 and 10. Come on. Yeah, those radical 3s, that's a big. Yep. So our numerator is -3 over 50 radians per second. Good. Okay? All right. So hopefully we feel a little bit stronger with that. Now let's get out your homework and we can play a little teacher with that. Your homework tonight is going to be to finish 5 through 9, but we'll go over 1 through 4 right now so that